Hi everyone, welcome to my YouTube channel, and in this video we will look at problem 91 from Leetcode. Here is the problem statement, and I want you guys to pause this video for a second, try to come up with your own solution before we look at my solution together. In an interview setting, when you encounter this kind of problem, I would say the first thing that should come to your mind is, well, try some simple example. So in this case, I have 11106. Now to visualize this, you can try like drawing this graph, and you notice that you can try maybe depth first search to solve this problem. But so that should be the first approach. And so here in this case, we will be looking at this first digit, and then we will be looking at the first two digits, right? And then we will be looking at the first digit here, and then we will be looking at the two digits after this first digit, and then so on. And then for here, we notice that this one is 0, and we don't have 0, right? Our A starts from 1, so when we have 0 by itself, then we do not count this, so we don't go to the we don't go to the next level beneath this. Same thing if we have something like 06. Well, 06 is not exactly valid, right? 6 is valid, but 06 is not. So I would say the first thing you can do is write a depth first search, and then maybe after that you can try to optimize the time complexity, like optimize the speed. So the depth first search for this problem would be something like this. So this is our depth first search function. If the index, so this is index, if current index is less than or equal to length of s minus 1, so this one should be n. Actually, I don't know why I put n equals length of s, but then I didn't use n, but so this one should be n, this one should be n. So we have n minus 1 and s, the string at index I is equal to string 0, then we return 0. Otherwise we return 1, right? So if I is equal to or greater than or equal to n minus 1, that means we are either looking at the last position of the string or even beyond, then we return 1. So that's the the base case for this recursive function, right? And then we initialize answer like local variable here, and then for k in range from 1 through 3, that means k will be either 1 or 2, right? We'll be looking at 1 digit or 2 digits, 2 digits at most, right? So when we are looking at one digit, then we check if this is equal to 0. If this is equal to 0, then we move on to the next one. So we will be looking at k equals 2, right? Otherwise, we run a depth first search for I plus 1 in this case. And then we will be incrementing our answer variable here. Otherwise, so that means when k is equal to 2, we check if the string of I colon I plus 2 is less than or equal to 26. If that is less than or equal to 26, we run depth first search of I plus 2. Now notice that if we have something like say 06, when you have int of 06, we get 6, right? Even though 06 is not exactly valid. So that's why we have to have this kind of condition here, so that when we pass say s of 0 colon 2 is say 06, then when we run DFS of say 2, we will get an error, right? We will get on some error here. So we will return 0 because that's invalid. But this one is very slow because we actually do have an overlapping sub problem in this case. But then our depth first search, this problem, we will be computing the same sub problems over and over again, right? So what do I mean by that? So I apologize for this horrible drawing, but so looking at that example 11106, we look at first digit and we'll be looking at the second two digits, right? The first two digits. So when we keep going down here, we notice that So think about this one. So this 11106, because we are looking at this 0, this is invalid, so we do not go further. Here we have 06. Notice that 06 is not valid, right? So this one, so it is not valid, we do not go further. And then here, well, it is valid and we reach the last index of this string, so we return 1 here. So this one, so this part 11106, and we are at, so the next one we will be looking at 106, right? We just looked at this second digit. Same thing here. This means that we look at the first 2 digits and we'll be looking at the third digit, right? This one, 106. So here we have a repetition going on. So this is overlapping subproblems here. These two are overlapping subproblems. So that's why memoization should come to your mind if you are using recursive solution for solving this problem. So here is the memoization. Another way of saying is this is a dynamic programming with top-down approach. So the only difference is that we have this scene, we have a dictionary here, and then if we have already seen this index I, then we just return this scene at I. Otherwise, we do exactly the same thing, and then when we exit, we make sure update our value here for our dictionary, and then we return answer. So that one, so this is if you do this one will be significantly faster than the naive depth first search approach. Now that we talked about top-down approach, we also have bottom-up approach. So this is a DP or bottom-up approach, and well, since I cover so many dynamic programming problem, I will leave that as an exercise. So this part will be initialization here, and then we'll be running from I from 2 to n plus 1. So this means in Python, this means up to n, not including n plus 1. And make sure you understand this recurrence relationship, and then we just return the last position of this DP array. So that's for this problem, and let's see how we can write this code. Let's see the code, and let's run this code together. Okay, so that's for this dynamic programming top-down approach, and I change that, instead of length of s, I just change that part to n here. Let's run the bottoms up approach. Okay, so let's run this. So that's for this problem. Well, maybe I can talk about Decode way, the second iteration of this problem series, but anyway, that's for this video. And if my video helps you guys understanding this problem, please give me thumbs up and subscribe to my channel.